Welcome to Spring LIB.
Hello everyone, today we're doing chapter 19, problem 6, and this problem asks us to rank the following compounds in order of increasing boiling point and determine which molecule is the most water soluble and which one is the least water soluble. So what we know about in terms of solubility, water solubility, is that the more polar a molecule is, the more water soluble it's going to be. And not only that, the more polar a molecule is, you can also determine that or say that the more polar the molecule is, the higher boiling point it's going to have. And the reason for that is, well, if you look at this first example here, well, we have a hydrogen bond acceptor and a hydrogen bond donor here. So this molecule can make two hydrogen bonds with all the other molecules surrounding it in solution, and that will do two things. Number one, it can make hydrogen bonds with water, so it would increase its water solubility. Number two, it can make hydrogen bonds with other molecules of itself, and therefore increase the boiling points required to break apart these interactions between these molecules to evaporate the molecule. So polarity is directly proportional or directly correlates with boiling point and water solubility. So we need to determine which one of these is most polar and which one is going to be least polar. Well, we already kind of determined for this first one. We have one hydrogen bond donor, one hydrogen bond acceptor. Well, now what about this second one here? Well, we have a hydrogen bond donor here, and then this alcohol group, it can also be a hydrogen bond, acceptor. This is a hydrogen bond acceptor. This can also be a hydrogen bond acceptor here, but we have electron withdrawing group that is directly adjacent to it, so it's actually going to take away some of this electron density and reduce the ability for this to hydrogen bond with neighboring molecules and neighboring water. So we can say that this first one is more polar than the second one. And now what about this one? So this one, we have just one hydrogen bond that could be formed. So because just one hydrogen bond can be formed, we right away can say that this is going to be least polar than either of those two, which can form two hydrogen bonds. So in terms of polarity, right away we can say this molecule here is going to be the least polar. So it's going to be least polar, so because of that, a few things will happen. Number one, we could say that it can have the lowest boiling point. Number two, it could have the lowest water solubility. But then we actually have to look at, again, its relationship to this one here. So in terms of number of carbons, we have 6 carbons, 7, 8, 9. This one will have 6 carbons, 7, and 8. So this one has more carbons attached to it. But this alcohol group is actually acidic. So what can happen is that this can fully deprotonate to an O minus. So if this fully deprotonates an O minus, now we can have ionic interactions with other things in solution. While this molecule here, because it has a methyl group attached to this terminal, or this carboxylic acid, or this ester, because it has a methyl group attached to it, you actually lose that charge that can be formed on this oxygen molecule. Not only that, you have some sort of electron density being withdrawn away from this oxygen towards this carbonyl oxygen, and making this oxygen less able to participate in your hydrogen bondings. So because of that, we can actually erase this trend that we thought would be true and say that because this is able to form a full charge, it is going to be more polar than this middle molecule that cannot generate any full hard charge on its polar atoms. So, for example, this molecule in the very first one, this one can get deprotonated, it's acidic, can get deprotonated and have a full negative charge. Same with the last one, but the middle one, you cannot have full charges here. So this is going to be actually least polar than either of these two molecules that can form full positive charge or full negative charges. So because of that, we're going to actually say that this molecule here in the middle is going to be the least polar. And because of this, the least polar is going to have the lowest boiling point and is going to be the least water soluble. Now, what about the most water soluble and the most polar? Well, that's something that's going to have the higher number of bonds. So we determined that now the remaining two they can both form full negative charges on this oxygen molecule here and here. So now that's a tie. We can have one full negative charge per each of these molecules. So now it comes into the intermolecular interactions that can occur with other molecules and with water molecules. So the first one on the left can form 2 hydrogen bonds, while the one on the right can only form 1. So because the one on the left can form more hydrogen bonds, it's going to be more polar, going to have a higher boiling point, and is going to be most water soluble. So it's going to have the highest boiling point, and is going to be the most water soluble. And this leaves with the last one for intermediate boiling point level. So intermediate boiling point between the highest and lowest options.